Now let's make a quick recap on how reinforcement learning compares to other domains of machine learning. In supervised learning, you generally assume that you have a dataset where you record not only observations, but also the optimal answers that some kind of expert gave you. And your main task is to get as close as possible to the opinion of this expert. Of course, this means that you need these experts to gather the data in the first place, and if you don't have, you're more or less screwed. So it's also very important that in supervised learning, you usually assume that your training points are independent of one another. And this basically helps you a great deal if you apply, say, a stochastic gradient descent where you want to sample the data. Reinforcement learning, however, lacks all those assumptions. You have this, first, you don't have a data set, as you have already noticed. Instead, you have some kind of system from which you can sample data, but you don't get reference answers, so there's no expert telling you what to do. Instead, you can try actions by yourself, and there is some kind of critic that assigns you positive or negative feedback. In case of online advertisement, this feedback was denoted as basically the money you get for the clicks. And basically this implies that whatever algorithm you use for reinforcement learning, you have to take care of exploring all the possible options, lest you risk to never try the optimal action and never learn it. The other problem with this reinforcement learning formulation is that your agent, your decision maker, basically affects his own observations. So whenever you, for example, whenever you try to ride a bicycle, if you always turn left on the first turn, you will never get data points where you ride on the part of the road which is on the right turn. Basically, you have to be very careful to explore the state space as well, otherwise you risk misrepresentation there and failing to grasp the entirety of your problem. The other domains, like unsupervised learning, also differ from reinforcement learning in a great deal. Unsupervised learning tries to, it doesn't have expert as well, but it tries to do a different thing. Instead of trying to learn an optimal strategy, it simply tries to describe the data, find some underlying structure. And this is very different from trying to find a strategy, because sometimes it's much easier to ride a bicycle than to understand the structure of it, especially when it comes to not a bicycle, but say a computer. Now, finally, it's important to remember that although there are those kind of features and bullet points there are no hard decision boundaries of what's unsupervised learning, what's supervised learning, what's reinforcement learning. Instead, if you try to solve any particular practical problem, you'll probably find yourself reducing it into some combination of supervised learning inside of reinforcement learning and unsupervised learning as a helper, maybe. But reinforcement learning is more or less the most general area that can be treated as the kind of the superset of all supervised and unsupervised learning here.